In this video, we are going to look at the quotient rule. Suppose we have two functions of x, u and v, and we have another function y, which is of the form u over v. We need to find out what dy by dx will look like. So we can write our original function u over v as u times v to the power of minus 1, and apply now the product rule. We can get dy by dx will be u times the derivative of the second function, which is v minus 1. So differentiating v minus 1 by dx, plus the second function v to the power of minus 1 multiplied by the derivative of the first function u, du by dx. When we differentiate v to the power of minus 1 by dx, we should remember that v is a function of x. So when we differentiate v to the power of minus 1, we should apply the chain rule. So we differentiating v to the power of minus 1 by dv times dv by dx. When we differentiate v to the power of minus 1 by dv, we are getting v to the minus 1 times v to the power of minus 2 times dv by dx, plus, instead of we can write v to the power of minus 1 as 1 over v times du by dx. And now u times minus 1 gives you minus u. V to the power of minus 2 is 1 over v squared times dv by dx, again plus this second term. If we would like to write it as a fraction, we need to bring two terms to the same denominator, v squared. So we'll have, from the first term, we have minus u times dv by dx plus v, because we have to multiply top and bottom of the fraction by v to get v squared here. So we have v times du by dx. And finally, rearranging these two terms so the positive term would be first, we can get dy by dx is v times du by dx minus u dv by dx over v squared. This formula is called the quotient rule, and you need to remember this formula by heart. In your exams, it will not be given to you. Let's start practicing. Here is the first question. Let's say y is 2x plus 3 over 1 minus 5x. This function is of the form u over v, where u is 2x plus 3 and v is 1 minus 5x. To apply the quotient rule, we need also to get du by dx and dv by dx. So let's differentiate u by dx, we are getting 2, and let's differentiate v by dx, we are getting minus 5. Now everything what is left, just collect all the pieces together. So we have v, which is 1 minus 5x, times 2, which is du by dx, minus u, which is 2x plus 3, you can see, times dv by dx is minus 5, divided by v squared. What is our v? V is 1 minus 5x squared. So now everything what is left is just tidying up. We multiply out the brackets, we collect like terms, and we are getting 17 on top, divided by 1 minus 5x to the power of 2. Here's the end of the question. Let's see another one, a little bit more complicated question. Okay, so here's an example. For example, y is 3x plus 1 to the power of 4 divided by 5x minus 2 to the power of 3. So again, we have a fraction here, and we are going to find dy by dx. We need to find u and v, and we need to find du by dx and apply the quotient rule. So our task here, let's write what is dy by dx. So our u is 3x plus 1 to the power of 4. since it is a function of a function, so we have to apply the chain rule to find du by dx. We have 4 times 3x plus 1 to the power of 3 times 3, which is the derivative of the internal function, equals 12 times 3x plus 1 to the power of 3. Okay, our v is going to be 5x minus 2 to the power of 3. Okay, so therefore, and here is mistake, so we need to correct it. So now derivative is going to be 3 times 5x minus 2 to the power of 2 times 5, so we're getting 15 times 5x minus 2 to the power of 2. Everything what is left is to collect carefully all the pieces into the same formula, into the formula of the quotient formula. Here is the formula, the quotient formula, where we applied all the pieces together, tidying up, collecting collecting highest common factor, taking highest common factor out of brackets, opening the brackets and collecting like terms gives us this result. All right. When you will be working on this topic, please make sure that you have checked every single detail, and if your answer doesn't match the answer given at the back of the book, then be careful with simplifying the terms, putting all terms correctly, dealing with negative numbers when you have, in this formula you have this minus sign, so be careful with any positive and negative numbers in here. That is the place of many mistakes in your exams. This topic is not that difficult as tedious, and you need to be careful with your calculations. Thank you for watching.